Michael Hotaling from ExxonMobil. Brian Nevinsky from Lockheed Martin. Francis Yu from Deloitte.
Guess we're really doing improv.
Yeah.
And Kurt Scheuringer from Amazon Web Services.
Guess we're changing it up.
Look at Kurt.
Right?
Way to go.
Quite the crowd.
I didn't know we had a rock
Yeah.
star on the stage. Holy smokes.
Who's the rock star?
I did.
Well, I don't know.
Very
I don't
The
know.
leather
Actually,
jacket.
I
cheering
lost
fan.
applause award to Kurt.
Thank you.
I
Thank
think
you.
I think it's Francis. Anyway, great to see everyone here. Thanks for sticking around. So first, I'm going to do a little table setting, so some context for this conversation, and we'll do some intros, and we'll dive into a nice, lively conversation, maybe a debate. Might get spicy at times. I'm counting on you to make it so. So a little background. So I'm Evan. I'm our principal specialist for spatial computing. Fancy term for business development and go-to-market. Been there for about 4 years, and I actually founded the team back in 2020 in the wake of our deprecation of Sumerian, which is a 3D browser authoring tool, RIP Sumerian. In those first 2 or 3 years, no one really gave a damn about spatial computing. I was running around trying to get people to invest and take it more seriously, and they just thought spatial was a fancy academic term to slap lipstick on the pig that was the metaverse or AR, VR. And so I was on a holy mission, and I started to run around and talk about spatial computing is everything. It's this convergence of the physical and the digital, and it touches all these different endpoints, and it's digital twins, it's robotics, it's simulation, and some people got it. Most looked at me like I was crazy, and I was this guy internally at AWS for at least 2 or 3 years. So then we started to get some people on the team, some smarter people than myself, and we started to think about how to make this a better story to tell and make it land better with our executives and have bigger, better business impact with our customers. And so, as the famous Charlie Munger quote goes, if you face a problem, invert it, and you'll see the solution. And so we've inverted it and thought about it not about the endpoints, but about the data. And we view the world through a data lens. And it's really a story about spatial data, and which we now talk about as world data, right? Data about people, places, and things, and really data about the most important thing most companies have. It's their products and their IP. And this data is woefully underutilized today. And so what we're going to talk about is how to develop a spatial strategy to unlock more value from this data. And I think it makes more sense for all kinds of reasons. It makes more sense organizationally, technically, politically. Because let's face it, we're all having to compete for dollars and attention, and AI is sucking the air out of the room. And so how do we matter in that environment? And the reality is this idea of a spatial data strategy is the foundation to even tie it to AI in some pretty compelling ways. So those are the topics we're going to hit on today. Let's start with some intros. Let's do quick 1 or 2 sentences from each of you.
Yeah.
We'll go into a quick background.
Good afternoon. My name is Michael Hotaling. I am the Operations Excellence Digital Manager for ExxonMobil. What that really means is I'm responsible for the digital footprint of all of our operating assets in the downstream refining chemicals, midstream lubes business.
Hi, I'm Brian Nevinsky. I'm a technical fellow at Lockheed Martin, and I'm our corporate spatial computing strategy lead, touching each one of the business areas and how we're going to use this technology to kind of advance what we're doing.
Hi, Francis Yu. I'm a partner at Deloitte. And at Deloitte, I run this business called Unlimited Reality. When we launched Unlimited Reality actually over 2 years ago, was really we brought together a business we ran over the past decade called Digital Reality, and a business that we been also building over the past decade called AI in particular from the intersection with AI and the experiential, the spatial side. So I'm really appreciate that you actually, one of these on behalf of the panel, I'm going to say thank you for actually hanging here on a Thursday afternoon between here and the airport. So.
I'm Kurt Scheuringer. I'm one of our principal prototyping spatial specialists, particularly work at AWS on our PACE team, which is our prototyping and cloud engineering team. It's a place actually that we consider one of the tip of the spears for working with customers and their use cases. We get to see firsthand on how they implement spatial, what their use case is, and kind of just help them along as part of that. And so through that, we've seen quite a bit of, again, the use cases and challenges and really the data problems that come about of implementing something that has to do with spatial.
Awesome. So as we created this idea of looking at the world through a data lens, it was so refreshing to see y'all's perspective, because you guys have a very similar view of the world, but also very different in many regards. So let's start with you, Michael. Can you talk to us about how you convince your team and your leadership that spatial data is important and the strategy needs to be implemented? And you want to use these?
I may want to use a couple of slides. The impromptu question. Let me see. Let me think about it. So let me first start, because I think I love the way it was shaped when we talk about spatial computing. But let me step back a little bit and make sure in the big picture, I'm sorry, but spatial computing in and by itself doesn't add value.
Amen.
Right? It's only when we start tying that to what I would say is people, work processes, and technology, right? And the concept, most people in the room here heard of a digital twin. This is a Venn diagram we've used out in industry quite a bit to just orient people on in terms of what we're talking about, right? The Venn diagram, very similar to what was shown earlier. You'll see the 2D, 3D models. This is where we believe the spatial computing will be. The bottom is really where data, yes, you can argue it's all data, but this is your traditional data sets. And the top left is where we have simulations and capability. And when that comes together, now I'm talking about solutions that actually solve problems and add value. Now, when we talk about it through our organization to talk to management, we really try to pinpoint of, look, a digital twin is nothing more than a visual representation of the real world, right? And this is where the spatial computing comes in, because we want to make decisions, right? We want to drive business value. Now, in these, you can talk about what is the maturity of a digital model, because in our industry, we are unfortunately prone and known for single use, build once for one solution. And to be honest, most of them die a slow death, right? Because it's a cost plus proposition, and frankly, it's one to where you can't sustain those models to answer that one problem. So when I look at the maturity, right, we talk about the complexity, the level of integration, number of use cases. And if you talk about the intelligence, right, this is a matter of, is it a feed forward? Do people use it just as a passive information? Or does honestly your digital twin start telling you stuff before it happens? And this, you can see how the Venn diagram comes together. The fidelity of a model, which is another key part of spatial computing, gets back to where the time and frequency. How often is it updated? Is it, if I bring everybody in the Wayback Machines when we started spatial, do you guys remember when, you used to align cars in the parking lots because the satellite was going to go over at 2 a.m. in the morning and you were going to take a picture, and that was the picture that was going to be painted on everybody's wall? I mean, if you think back 30 years ago, that is what we did when we started looking at geometry. Now, from a technology standpoint, you have the question of how often do you update it? And the more frequent you update that spatial model, now think about the maturity and complexity in terms of what you can do. I think the measurement and the accuracy is also responded to where the values come. We have cases where thousandths of an inch is critical in terms of doing work. And then I have other areas where, quite frankly, you get me within 3 meters, I will drive 90% of the value. So when you look at this in terms of the parameters of spatial computing, putting it together as a digital twin becomes a critical part. At ExxonMobil, we are building a digital reality ecosystem based on 4 pillars. Agnostic capture. When we talk about spatial, we talk about capturing, being sure that we can fundamentally separate hardware from software, and as it says here, separate software from data. In order to grow the value in terms of what we're trying to drive, the data must be able to be separated from the software. And if I move over to everybody's favorite AI/ML, I need to be able to separate the models from the platform. Right? In our industry, in terms of taking and harness that technology, doing that in a very democratized way is critical for the growth of use of spatial digital twins within our organization. I'll skip through some of the other words here because a lot of people ask me, it's like, well, Michael, where is the value? So let me just quickly go through 3 or 4 use cases. I'll flash it up. You know, when you talk about spatial computing, you get into a debate often within the company where people is like, oh, look, I have a 3D model. And I'm like, yeah, it's nothing but a dumb picture, right? But a dumb picture does have some value to it. It may be limited, but in terms of capability, when you start growing that, in terms of interacting, what I would say is projects, point clouds, right? In terms of coming together, now you're in the point where you can drive more and more business uses. As depicted here, whether it's internal, external, for those that are in manufacturing, used to run around with chalk paint and circle things for inspection. Now, from a geospatial and location, you can do that today using the technology. From an efficiency play in terms of organizing work, it's amazing of how you can use the technology to solve real-world problems. And these are just some other examples of where mixing reality and engineering and together can continue to drive. The critical part is if you're going to do that, you need to have geospatial aligned on a coordinate system that can be reused over and over again. So that's how we are selling this story within ExxonMobil.
That's awesome stuff. It's one of the more comprehensive perspectives I've seen in the space. So that's the view from the world of a company that's managing infrastructure, pulling stuff out of the ground, but you guys aren't building a net new product. You're not an OEM the way that Lockheed Martin is. There's some unique differences when it comes to, okay, you're designing a thing from scratch. It's in the PLM system. Can you speak to about some of the other things that you communicate to your leadership in this realm of a spatial data strategy matters in the context of developing products like yours?
Yeah, a lot of it ends up being speed. It ends up being reliability. It ends up being overall efficiency to get things done. So when you think about, for example, we've made these engineering changes in CAD and PLM, and then you want to eventually get these things downstream for people to do their analyses in a real-time 3D environment, whether that is manufacturing validation or ergonomic inspection or some sort of validation of work instruction or training or any of those use cases. If we're not making all of those connections in some common hub point and knowing when things are updated, you're not really allowing for that efficiency. But if we can make these connections of spatial data to your engineering data, your associated metadata in a common way, and we can kind of have all of those systems connected and integrated in a way where we can say, hey, I pushed something out to production here. We're going to say this is accepted from an engineering sense. We can have listeners when we do all of our conversions and optimizations to say, now in this common hub, rather than doing one-to-one individual conversion and optimization pipelines to each of those use cases, I can be one-to-N, right? And to have a strategy that allows me to do that greatly increases my efficiency and make sure that I'm not doing work on old data and then, oh crap, I have to redo this, right? All that analysis I did on manufacturing validation or whatever, or ergonomic inspection, is a moot point, and I have to go redo it again. Yeah. So the time savings and cost savings there is a big one, and then it also gets into, we can look at, say, quality inspection, for example, and making sure that you have kind of a source of truth to inspect against, and then making sure that there aren't things in an area where there shouldn't be, that things are manufactured the correct way, that there's no damage, and having that source of truth and the connections through there is going to allow you to go do that. We can have that from a common hub of all these conversions and links out to those common sources of data. Quick
question on this idea of a source of truth, though. The most common question we get from people is, well, PLM is our source of truth. Why can't PLM do this? What is your go-to answer to that question?
So
a bit off script here, so apologize.
Yeah. So a PLM to me is like a good place to store your lifecycle for your CAD, right? And things that are in that format or from your other source engineering systems. But when you're bringing it out to a real-time sense, that's not gonna be super performant in a headset that needs to render at 60 frames a second so someone doesn't get sick, right? So you do need to decouple that polygonal data from your other engineering data and metadata and then recouple the things only that you need for those experiences.
Got it.
So after you've gone through that conversion and optimization, that's not storing in the PLM system. That's kind of a new format that's been decoupled, and we need a new place for these decoupled artifacts to be able to recouple them as you need them, as a service out to these individual real-time 3D systems.
We'll geek out on that a bit more down the road here. So Francis, you have a very unique purview of lots of industries and lots of verticals. What is your kind of talk track around convincing people that, hey, a spatial data strategy is important?
Yeah, so we go back into when you talk about all those, the data, the projects Michael and Brian talked about, fundamentally going back to elevating what? Elevating human experience. So for us, we always talk about what does that mean for human. And that's why over the past decade, and at Deloitte it's not a hard sell at all, because we've been tracking the technology trends over the past decade. We had longitudinal data. And what we have learned here is that there's a tremendous amount of innovation around this notion of spatial web, and we've been championing this for years. And across all the three layers of the internet, interaction layer, the computation, the information layer, we've seen tremendous amount of investments, IP, putting into this. And what is this translating to? So at kind of a micro level, we're seeing real movements in terms of enterprises adopting this, what Michael, I would credit you for really championing this, is the visual-led way of working. Last year, we did a study with Manufacturing Leadership Council, and we surveyed over 300 or so execs across different industries who focus on complex manufacturing, product design, engineering. And you know what? One of the things they told us consistently, over 90% of them are implementing one or more use cases that fit in the category of spatial meets intelligence, spatial intelligence and visual-led way of working. And for the pace setters in that peer group, you know what? They're looking at over 8+ concurrent use cases. So that's incredibly exciting. And I would wanted to show a little bit, because to be human is to see, right? So this wave of digital transformation is incredibly exciting, and I hope you see some of those kind of scenes from real work, a compilation of real work from our clients would make you feel that also, that seeing through the eyes of human. So let's see if the video works.
Let's see if the video does work. Friends in the back, if you can fire it up.
As reality evolves, we enter new eras. Eras of creativity, industry, and technology. Today we are entering an era of new dimensions, where reality becomes unlimited. An era where factories and stores are built virtually before laying a single brick to lower cost. An era where 3D training environments improve workforce safety and workplace satisfaction. An era where new immersive experiences allow brands to connect directly with their customers to increase loyalty and affinity. An era where spatial data flows across the business with intelligence and automation. A brand new era where 3D imaging and synthetic data can help evaluate infrastructure. The unlimited reality era is here.
I was going to do it for. Awesome. Love me a good sizzle reel. So the hard part is making all that real. And there's so many things getting in the way of that. It could be cultural challenges, political challenges, you name it. I think one of the best ways to wake people up and break through those barriers is to create mental models that people can understand and wrap their head around. You had a couple you mentioned: separate data from apps, visual way of working. These are sort of mind viruses that people can latch onto. You have one that I love about spatial data and how to think about it in a way that even a 5-year-old can understand, hopefully. So do you want to talk to us about that mental model?
Absolutely. So one of the things when you talk about spatial data is you have to understand what we're working with when we say spatial data. And so one of the slides I'm going to come back to that Evan had up too quickly, I think, went through, is our spectrum diagram of what we're talking about when we even talk spatial compute. And you'll see actually XR is kind of at the center, but XR is just a last mile delivery device, right? what XR really means is just a platform that has certain constraints, certain requirements to how to display this data. And when you look across the whole spectrum, really where you look at robotics, IoT, even Gen AI, VFX, all of these are driven by just 3D data in the backside. So at least at AWS, one of our core things is, how do we manage this data, right? How do we ingest it, store it, transform it? And on a better sense, right, this data sometimes has to, or in most cases, needs to be hygienic. And we have to start tracking lineage of this data as we're transforming it. And so part of this is understanding what 3D data is to know when we're talking about, let's say, spatial data planes as one of the solutions coming up, to know like how to manage this data. And one of the best cases that we talked about as part of this mental model is Legos. Everyone knows Legos. And actually, Michael, I appreciate, provided a previous slide to this that also had a similar mental model. And
Great minds think alike.
Absolutely. And a lot of people coming actually back to the PLM question or even Perforce or think of just like even a SharePoint. People are like, why can't we just use that to store our files? And you got to think about if you use those sources, look at the data pile of Legos. They're just a bunch of different files, right? They have no relationships between themselves. And then look at the AWE story picture, right? It's a picture of a bunch of Legos built together that describe a scene. And you can picture these as the data pile just being, if you're a games company, could be an avatar, could be a tree, could be something small. If you're an engineering company, could be a screw. When you look at the full picture scene as the AWE logo, you're thinking more in a game term, right? A full game scene with all your assets loaded. Or if you're talking engineering company, could be aircraft of some sort or a vehicle all put together. And in reality, the only difference between those two piles is the relationship between all the data elements. Relationships in 3D are everything, right? Without saying this screw is part of this next assembly, which is part of an actuator, which is part of a car, you have really just screws and a bunch of individual parts. And it's the relationship between those that matter in corporations as they build up these assets. And so when we start talking spatial data management, really we're talking about taking these smaller pieces and really storing and understanding the relationship between these pieces. And that becomes very powerful. Because now as you can start storing the relationship between these, as Michael, you brought up, things change.
Right.
But we need to know where things came from and where things are going.
Space and time.
Yep.
Absolutely. And when we transform them from CAD to mesh or point cloud to mesh, really we'd like to know what was the original file. And if that file changes, what are all the cascading effects going down of all the things that also need to change? For those that watch Silicon Valley, they have a middle-out compression. I always say, actually, in this data pile, most established corporations actually work in the middle and work outwards, too. Yes, they have small piece parts. They have the screws. Yes, they have the full assemblies. But a lot of time, they're taking existing small pieces, and they already have some actuators built, right? And they're just building a new car, right? If we're an automobile manufacturer, they reuse a lot of things, but they just replace. And so really they're working in that middle set where they already have a lot of assets built. Yes, they're building new. They also have a lot of assets that are at the top, but they're always in that center category. And as part of that, we need to make sure that we're tracking in all different areas, but most corporations actually sit right in the middle when they're usually building out new things. Not always. But this is one of the main mental models that I wanted to at least bring up as we start going down this journey. And a little bit in today's conversation, you'll see how we're going to start laying that out into systems. But at least this gives you a picture of like why this is important. And this goes down even a further rabbit hole, right? If you start looking within those data files and the points, the lines, all the other information, that's a whole nother bucket that we're looking in the future on how to tackle.
It's good stuff. So this is a great technical mental model to grasp the so what technically. Are there any other mental models you guys are seeing that work in terms of like operational stuff or
I was going to say, this is actually one of our biggest problems.
biggest problems? Okay.
Yeah, and the reason why is because we're not talking about engineering tools for engineers. And I mean, if you think back, 15 years ago, we were literally building models of things in plastic or clay, et cetera, right? And one of the things that is plaguing our ability to move to a visual way of working is getting out of that shell. Because when people start talking about, PLM, it's like, okay, bring your hammer because all I got is nails, right? There is much broader aspect in terms of moving to a more visual way of working, how we physically interact, how we do work. In that, when you talk about geospatial, like I want to track people, I want to track cranes, I want to track space and time of movements. These are all beyond the assets. Yes, tracking components of an asset, an MCAD model, in terms, it is critical. But what is killing what I would say is the adoption and the growth is that every time you start working, people get into that mental model of, oh, it's got to be, associated with the asset. That is a use case. In some cases, depending on your business model, those use cases have much higher value than others. But I think if I stand back and think about democratizing data so that it can be shared across an ecosystem, we have to actually step back and get out of building engineering tools for engineers. You need to get spatial data that is plug and play with a number of applications. Look, we were on the floor today, and unfortunately, a couple of conversations with a couple of suppliers didn't really go very well, right? And because part of this was around, guys, I'm not building a bespoke solution. You're not building an application in geospatial for one application. To me, that is the road to a slow death in terms of capability. This is about building an ecosystem where spatial data is democratized, is consumed, and it is digested based on open standards.
So quick, just to move us along a bit here, to create that environment, what are some key conditions that need to be true within the organization? And that could be from a technology perspective, business perspective, so on and so forth. And it would be good to go down the line on this one. Maybe we'll start with you to mix it up here.
Yeah, I mean, in order to have that, hey, we're going to make this for everybody, you have to start first. We didn't even just like say some of your user experience workshops of what does everybody even need in the first place. And a lot of times, especially at the enterprise level, we don't prioritize user experience at all, which should be driving a lot of your requirements. It becomes, we see user experiences like sprinkling on your aesthetics at the end when it is the core of a lot of these experiences. Also, we can go ahead and make all the like whiz-bang everything you want and say that it's going to support everybody. But the teams that are making them usually aren't the ones that are going to be supporting them long term. Like it'll come out of maybe a business area, and then you're going to hand it off to an enterprise team that's going to, support it for an entire set of business areas. And they have to have headcount, they have to have budget, they have to have the skills to go do this, they have to have the willingness to take on something that's new and scary, right? And speaking of mental models, like they don't have the mental models of why it's valuable in the first place. Because it's not something they use in their day-to-day life. So my phone, for example, how did this get into the workplace, right? So we had people using their mouse and keyboards, right? And then you had people using BlackBerry, and it was a pretty quick abstraction over to that. You had your little stylus or ball, and you had your physical mechanical keyboard on there. And then to get to a touchscreen was not that big of a leap from there. But to go to a headset, right? There's not really much similar there from your phone to a headset.
Similar or dissimilar?
Yeah.
Which one? Is it you're saying it's similar to a phone?
I'm saying it's very dissimilar.
Very dissimilar.
And people aren't using that in their day-to-day life,
Yeah.
so they're not understanding the value. So you also have to have people that are going to be taking that over, understanding and caring. And you're going to do that again, kind of wrapping back around to user experience, because you can explain, once you know what their problems are, how this intervention is going to be helpful for them and other people.
That's good stuff.
I don't think people are going to be wearing, headsets, every day in their lives. I mean, we had a dinner conversation. To me, there's an opportunity where it adds value, and I agree with your comment, Brian. And that opportunity is not for everybody. This is back to the whole, hammer and nail thing, right? It's a matter of where we see those applications, great. But long term, I mean, what's out on the market today is not going to meet industry's needs.
Yeah, that's for sure. So on the theme of conditions to be true, and also just to throw a wrinkle in the question too, an order of operations to create those conditions. If you have any ideas to like what things need to happen to create that conditional state, that would be interesting.
Yeah, so we have a term, and for those of you who followed through the looking glass, you know the Red Queen syndrome, which is you're running ever so faster, but you stand still just to be stand still. And that's a syndrome that we have seen a lot across enterprise, where you have a lot of acts of innovation, snowflakes of innovation. And when you're looking at how you actually scale from the center of innovation or from the local innovation to the frontline worker, to the people that actually going to make your business case work, then you start losing that line of sight to value. And then sometimes with that inability to articulate what's actually value you're creating for the innovation throughout the enterprise, that's when projects get shut down. So one of the condition, number one, is to start with that whole end user and value pool in mind and work backwards in terms of how the technology, different pieces of technology across the stack is going to make it work. And second part, the condition is, do you have the internal stakeholder ecosystem to actually understand this whole value story, have a champion, and do you have external ecosystems of innovators and of the village that with you to make that happen at this early stage of scaling innovation, right? So that's kind of the couple of thoughts on the condition.
Yeah. You have all kinds of scar tissue around this topic.
No,
so
I do. I guess one of the things I was going to say is that if I narrow my lens and we talk about geospatial in terms of an open ecosystem, one of the things that is limiting the adoption and growth of the ecosystem is actually a democratized agnostic central storage. And I say that because we're not moving around 2 megabyte files. Right? We're talking about some of these terabyte-sized files that we want people to interact with depending on the persona associated with what level of fidelity. As I shared before, fidelity, frequency, level of data. Like, are you going to try to render a 18 terabyte image on your phone because you're trying to do AR? No, you're probably not going to do that. So finding a way to scale that, I think to me, this is the area where I would say ExxonMobil and AWS have a common vision, right? Getting to where I would say is, thinking about cross industries and the time we spend outside of our own industry, where you talk about democratized, centralized storage that is part of an ecosystem that people can plug and play is a critical component in terms of moving this geospatial compute to the next level.
Amen.
And one thing I want to add on to that, right, when we talk about democratized data, it should also be, right, an agnostic system, right? And there are a lot of vendors out there that provide software that say, yeah, we can store your data, but if you look at it, they sometimes can't even turn over your data because it's stored, again, and to your point, not in standardized formats, things that you can move between systems. So I completely agree with you, and we need to make sure that no matter what system it's stored in, it can always be transferable. It can be moved out, converted, whatever the case might be. I mean, that is so important.
So, I mean, it begs, to where, do we have the right standards in place? Right? Because if you're going to go to open standards, open agnostic, there are areas in the space where I would say the standards are not fully developed. Right? This is where you have to be careful of, not getting into the monolithic lock with a certain supplier, and then, heaven help you, you're trying to get your data out of that system, right? To me, this is the area where, quite frankly, we want to continue to reward rapid innovation in terms of capability on that, centralized or agnostic storage to really deliver from a consumption tool to the persona that actually needs the level of fidelity to drive the value of their use case.
So some people are probably listening to this and thinking that it sort of rhymes with some old themes and initiatives that have been in the space for a while, like the idea of a model-based enterprise within industrial manufacturing, or the idea of a digital thread within the public sector. How would you guys say that a spatial data plane is different than that? And this is where we can not so indirectly plug some AWS stuff. Kurt, if you want to start and maybe pull up the next slide. Talk to us a bit
Love these
about
random questions.
talk to us a bit about the unique characteristics of a spatial data plane from our perspective, selfishly, and then we can let these guys go as well.
Sure. One of AWS's visions is, right, like how do we solve everything we've just been talking about here? And how do we do so, right, without being, or with being agnostic, not being like locked to like one specific product, right? Like those are some of the challenges that we're racking our brains of how do we do this? And we really look for us at AWS as what is our core service? AWS is all about data, right? We're all about data storage and transformation and compute. How can we leverage some of our very basic services that we have to help put some of these things in place? And so one of the things you'll see on this slide, right, is like you have all the data ingestion that comes from all these different places. Now, that can come from PLM, that can come from Perforce and some of these other systems, but a lot of those are either, again, vendor locked or very restrictive or for specific point use cases for engineering, what have you. So we want to say, okay, how can we integrate with all those different pieces and store, again, in a very ubiquitous manner that allows anyone to really access this data through a simple API structure, that sort of thing. And so when you look at the middle tier, we said, okay, well, let's form a data lake. Data lakes are very common, right? Even in like model-based engineering, data lake is kind of the central for a lot of those pieces. And even when we talk about digital threads, this is also a form of digital thread, but just a little bit more open. We still want to be able to track all these different places that data is coming in. And then we use services now just for basic storage, tracking those relationships that we talked about, just using simple tables, right, with DynamoDB, which is basically a way just to track record level storage between these areas. And then also a way that we can integrate all sorts of different pipelines and transformations. And what this means, right, is a transformation could be a conversion, whether you're talking about from CAD to mesh, from point cloud to mesh, or even just optimizations, right? There's tons of optimization tools based on the tools you want to go to. And we just wanted to make it easy so different partners, different ISVs, different customers can plug in their own tools and just make it easy to scale that solution. And going back, I think, to some of the core characteristics, I think scalability is really a big issue that customers have. Whether they deploy on site, even in the cloud, right, they need to have the right solution. So whether you're running an optimization on 1 terabyte point cloud, or now you have 1,000 that you need to process fairly quickly, we provide now solutions through this that allow you to provide that scalability, quickly spin up those instances to be able to do those conversions, and then really get to the endpoint, which is now whether it's either other AWS services or could again be tools that customers have made, their in-house solutions, could be partner solutions, ISV solutions that are now on those XR devices. And part of that is one of the systems that we call VAMs. VAMs is our visual asset management system. We just rolled out our version 2 of that this past weekend. And this is now a solution that uses these core services to help provide a way to start implementing the spatial data plane at a very basic level. And from there now, we would like the Deloittes of the world, everyone else, to now start building on that, making their robust grade versions that our customers can now use, but always have a fallback if needed, right, that there's still something open source, there's some basic way that you can get to what we've been talking about today.
Yeah. So this is a very cloud-native approach, and for you guys, let's be honest, these are older businesses that were not running to the cloud when it first became a thing. I think you guys are still in your journey to convince people to move certain workloads to the cloud. How do you guys talk about the cloud internally? You guys have security requirements. You guys have user access requirements. There's certain considerations that people should be thinking about when it comes to like old school enterprise IT environments here.
Yeah, I guess the way I would start, like this is really around, it depends in terms of capability. But a couple of key things, data sovereignty is king.
Yeah.
Right? And I think we've said this before, whether it's geospatial data, I don't care of any, type of the thread in terms of supporting our operations. Data sovereignty is king. And I think from a standpoint, whether that's in our own on-prem lake or that's in a cloud or a hybrid, I mean, at some point, you're paying for compute, CapEx or OpEx, however you're going to manage it. You know, security associated with that data is a critical part. To me, it's like one of those where I'd rather focus more on, you know, what is the ecosystem that you're trying to drive, and then come back to what is needed to support it. I don't think this is an area where you go pick your car and then you find out that you're on a Formula One race car with your or track with a NASCAR going, yeah, but I picked the cloud, right? You know, I think it really needs to make sure that, you know, you think about the architecture, and I like the way that this is set up because it really echoes some of the vision we have of the ecosystem of independent capture, store, deliver, and consume. And I think those items, the interesting part will be, I didn't say the word cloud in any of that. I think, you know, this is an area of how do you build an ecosystem that, depending on the needs, look, I mean, we have some areas from a geographic standpoint, you're not going to get, you know, 5G in the middle of nowhere of West Texas. So giving somebody an app that says, run it off the cloud, you know, the telecoms or whether it's Starlink, I mean, there's multiple mechanisms. There are some where, frankly, the most important user experience, back to what Brian was saying before, could be on-prem. So I think it's a little around, you know, let's make sure we understand what problem we're trying to solve in terms of the data needed, and then let that determine, you know, what is the architecture to support it.
Awesome. Yeah, I'd agree. Security is a big piece of that. The sensitivity of your workload can really dictate where that's going to be. Export controls can dictate where that's going to be. But what are you going to do with the data, right? That a lot of times dictates, can that be out in the cloud? Does that need to be really, really close to me? I may need to be in, you know, approximate location to that data if I need to do a lot of heavy processing on it and streaming it. If you're streaming it real time to someone after doing some processing on it, that may have been some heavy duty AI, that in and of itself introduces enough latency that you may be doing some, you know, lagging on your frame rate. You don't want to introduce more by having an even longer round trip, so you may have to have that pretty close to you at the edge. Versus some other things where latency may be relatively acceptable, like, you know, a few seconds of latency, maybe I want to snap a picture, get some intelligence on what's in there, and send it back to a user to, you know, overlay something for them to see. That may be fine, right? But if they have to do something in real time, you may have to have something right there. And then depending on, you know, whose data is it, what are maybe ITAR regulations on that, it may say, even when you're in the cloud, is it going to be in a public cloud? Is it going to be in a government cloud? Does it need to be down in our data center?
Got it. Well, as fun and exciting as data security is, I think we can end on a more fun note. And we'd be remiss to not talk about spatial plus AI. Lots of conversation on the topic here. We all know the use cases that are possible. We had the guy from Iron Man up here. The whole Jarvis experience is maybe the most obvious one. There's content creation ones. But there's certain things that have to be true at the data layer to go train these models in the right way. And so I think, Brian and Kurt, you guys have some pretty unique perspectives on what having the data organized in this way can do for AI and why that's the case. Can you speak a little bit to that?
Sure. And so, you know, generative AI, now everyone really knows what it is, but when we start talking about like spatial generative AI, it changes the picture a little bit, and we don't have a lot of foundational models out there yet, just in the industry alone, that can deal with 3D data. So what we still have to rely on is, you know, multimodal models that can pull in 2D, working with just, you know, I call it 1D data, your textual data. And 3D provides a lot of context just by itself, right? We talked about those individual data elements. One file itself, right, has all the relationships for what you need in there to be able to build that model. Generative AI relies on clean relationships, clean data. And so by having, for example, a spatial data plane where you now have not only within the file itself, but the relationships between all these files, now you can start making certain inferences, right? We can start building up scene contexts and start auto-labeling data based on all the various components that are in that scene. And having that both in the cloud, and I think to you guys' point, also at the edge, because there are a lot of applicability for also running like Gen AI models at the edge for certain quick things, especially when you want to do video processing, quality control checks. Like, if you're going to wait to go to the cloud on some of those, like, it may be too slow for you. So we need to make sure, to your point, that the data's in the right place and the relationships are maintained. So when we do run those algorithms or models in the cloud or at the edge, we have the data at the right spot to be able to now inference those models and eventually train those. And training takes a lot more processing power. Generally, you do that in the cloud, but there are now cases, right, when we start talking Gaussian splats and that sort of thing, that training can also happen at the edge. And the more data that we have that's hygienic, clean, relationships maintained, just make those better as they process.
I love that comment. So at some point, somebody's going to have to define for me what the definition of clean actually means.
Yeah.
Right? If I had
That's
more
a
people
whole
come,
that's a whole topic in itself.
We'll get our bingo card out. You know, we got edge computing in there. Oh, you got to talk about clean data because nobody wants to work with dirty data.
So I would actually say that if you're looking at a lot of the discussions, debates, to me, putting the AI and XR to use and learn it today, test, learn, that's what's impactful. And I might share a very quick story because we're in California, wildfire, even this week, destroy tens of thousands of acres of land. We helped a utility company in California doing what? By using edge AI, flying drones, computer vision, decisioning at the edge, and then apply that to our field inspectors so that we can help them to cut down the inspection time per asset by 5 minutes. We can improve in terms of the inspection image quality by 78%. And we can also help keeping our folks safe, not only the folks impacted by fire, but also keeping our inspectors safe. So those are kind of cases where when folks talk about, hey, where we're at, I mean, it's real thing is we're going to get started doing and learning, right? So.
I love it. There you go. Spatial data planes is your way to go get those AI budgets that are out there. So wield accordingly. Well, this is an awesome conversation. We're at time. Thank you guys for sticking around and listening. And hopefully this was useful. We'll be around for questions if you guys want to dive deeper.
Yeah.
Very good.
Thanks.
Thank you.